Hi everybody, here we are checking out the solutions to the second practice review here for the 1.5 to 1.10 test, which is very soon. So this first one is a rational inequality, and once you simplify the left side of this inequality here into one fraction, it's actually a pretty nice fraction, x plus 7 over x minus 2 greater than or equal to 0. So your critical values there are negative 7 and positive 2. However, we can't let x actually equal positive 2. That would make the denominator 0 and therefore undefined. But it works out that values that are positive for that fraction happen when x is less than negative 7 or greater than 2. And I should say less than or equal to negative 7 because it's okay for the value to actually equal 0. Yes. However, I can't let it 2 for reasons I stated before. So there's my solution from negative infinity to negative 7 union 2 to infinity. And pay attention to the notation there. I include the negative 7, but not the positive 2. Okay, next problem. Much simpler. It's already in factored form, so your critical values are at 1 and 4/3 for that quadratic there. That's a tight little region, not very much space in between them, but you can figure out that it's positive to the left and to the right and negative in between. You can sort of imagine a parabola. This would be a positive parabola, which would mean that it comes down and crosses the x-axis at these two places. So it is below the x-axis in between these two zeros of that polynomial. And there's our solution, less than or equal to 0 from 1 to 4/3. Okay, next problem there. Finding the equation of a line that goes through the point negative 3, 6 and has an x-intercept of 2. Well, that means the x-intercept of 2 means that the coordinates 2, 0 are on the line. So all I have to do is find the equation of the line that goes through those 2 points. Well, first I figured out the slope, and it gives me this number negative 6 over 5. So I'm going to use the point slope form here to get things started. Putting this point in, there's my x and there's my y, so I'm going to say y minus 0, and that equals the slope times x minus 2. So I work that out and I get this equation right here. Yeah, it's a little ugly, but in slope-intercept form, I get negative 6/5 x plus 12 over 5. And moving on to the next question, a little bit more involved, but still finding the equation of a line. I have to find the equation of the line through the center of this circle, and through that point, and it goes also through the positive y-intercept of that same circle. So here's my working out using completing the square process here to find the center of this circle, and I get the point 3, negative 1. Now to find the y-intercept, I did mention that a graph may help here. So I did a little sketch here with a graph. There's the center, 3, 1. I figured out that my radius is 5, right? So that, because I got that 25 there. So the radius is 5. So I'm looking for, when I sketch this circle out, it's kind of a crummy drawing, but you get the idea there. It crosses the y-axis right up there someplace. And a couple of different ways you can find this. One way is to think of this radius as being the hypotenuse of a right triangle. And if you know that this point is 3, negative 1, that means the distance between the y-axis and the center is 3 units. And if that is 3 and this is 5, well, there's only one possible length for the hypotenuse there, and you can work it out with the Pythagorean Theorem if you want. But this is a 3, 4, 5 right triangle, so that side's 4. That means if you work that out, that has a y-intercept of positive 3. You could also plug in 0 for x into my equation for the circle right there. Put a 0 in there for x and work it out to solve for y. That's also not too bad when you actually start doing it. That makes positive 9. I'm sorry for the fuzziness here in this video. It's pretty bad. But that way, that makes 9. So I subtract that from both sides. I get y plus 1 squared equals 16. I work that out and I have to get y equals 3. For the positive y-intercept. Yeah, there's another y-intercept down there, but I don't care about that one. So there's my point, 0, 3, and 3, negative 1, and I work that out, and I get this equation for a line right there, y equals negative 4/3 x plus 3. Actually, that's pretty easy because I know the y-intercept is 3, and I can work out that the slope of this line here is down 4 and over 3, so negative 4/3. Let's move on. Completing the square, And the next problem was a piece of cake compared to that one. Just adding half of that number squared and half of that number squared. And I get this equation right here, x plus 5 squared plus y minus 3 squared equals 20. That means my center is at negative 5, 3, and the radius is the square root of 20. Moving on. Next problem about a certain rectangle. This wasn't such an easy problem, actually, but check it out. Let's see how we did this. I'm given the information that the diagonal of the rectangle is 6 more than twice the length of the shortest side. Also told that the perimeter is 68. So if I say that's the shortest side and I call that x, that means if I think about it for a second, the diagonal 6 more than twice the shortest side, so that would be 6 plus 2x, or 2x plus 6. Now, this other side here, there's a couple of different ways you can find that. I decided to go at the approach, well, I don't really know what it is, but I'm just going to call this side x and this side y. And if I know that the perimeter of this thing is 68, I can write a little equation, 2x, for those two sides, and plus 2y equals 68. When I solve that for y, I get 34 minus x. So that's the length of that side in terms of x. Very important. So now I've got 3 sides of a right triangle, and the Pythagorean Theorem comes riding in to save the day. And so here it is. There's my Pythagorean Theorem worked out there for each one of those expressions. Lordy, those look kind of difficult. And yeah, the numbers get kind of big. There's x squared. This is 1156 minus 68x plus x squared. That's what I get when I square that binomial. When I square this binomial over here, I get 4x squared plus 24x plus 36. Rounding everything up and setting it equal to 0 gives me this big old quadratic here, which I decide to make it easier on myself by dividing everything by 2. So I factor the 2 out of each one of those terms. I get 2 times x squared plus 46x minus 560. And you know, after playing around for a while, I figured out that this does factor because 10 times 56 equals 560. And if I just subtract 10 from 56, I get positive 46. So yeah, there's the factorization of that thing. And of course, you could use a quadratic formula. You get the same numbers. The answer for x is 10. You also get a big negative number, negative 56, but I don't really care about that. That wouldn't really apply to the length of a side of a rectangle. So it's 10 inches that way, and it's 34 minus 10 on this side, which makes it 24. 10-inch by 24-inch rectangle. Okay, flipping it over. It's got some equations to solve over here. This one, fraction buster, common denominator, 2x times x plus 3. Each one of those terms, you've seen this many times by now, folks. So that boils down to a simpler quadratic, which does in fact factor to 3x minus 1 times x plus 6, or my answers are 1/3 and negative 6. Fortunately, none of those cause the denominator to be 0, so I can use both of those solutions. The next problem is a radical equation, and I want to isolate the radical first by moving that 9 over there, 3x minus 9. I square both sides, and I get 7x plus 1 over here, and this whole thing squares out to 9x squared minus 54x plus 81. When I set that to 0, I get this monster-looking quadratic, which turns out also to factor. That might take you a while. You get 9x minus 16 times x minus 5. Interestingly, you get there's another possible factorization of this, which is kind of weird. But anyway, x equals 5 is one solution. X equals 16 over 9 is another solution. But 16 over 9 doesn't work. And it's always important to check your solutions in these radical equations especially. When you put a 5 in there for x, and by the way, I used this little version of the equation just to make it simpler. I thought it was simpler anyway. To put a 5 in there for x and x there. And that works out like this. 7 times 5 plus 1 equals 3 times 5 minus 9. That's 30 square root of 36 equals 6. Yep, that is true. It's interesting when you put in the other value, 16 over 9 for x. And we work that out, you get 121 over 9. And those are both perfect squares, so this is kind of interesting. And when you put in 16 over 9 on that side, 3 times that, that's 48 minus 9, minus 81 over 9. Well, right away you should think, well, that's a negative value. I'm not going to have a square root equal a negative number here. Although it is kind of interesting how it works out. You get 11/3 right there by taking the square root of those, and you get negative 11/3 over there. So it's kind of a head scratcher how those numbers work out. Not really. But anyway, just thought I'd point that out. The actual solution is just x equals 5. The other one is extraneous. It does not check into the problem. Next problem there in this group is a rather simpler problem of cross multiplying. You get 3x minus 2x equals 21, and that works out to a fairly factorable quadratic. You're getting a lot of practice factoring quadratics here, aren't you? X equals 3 and x equals negative 7/3. End of story. Let's do the next one. Solving for x, also a factorable quadratic type. It's not really a quadratic, but it is in quadratic structure. It factors to x squared plus 9 times x squared plus 6. Whoops! That gives me x squared equals negative 9 or x squared equals negative 6. No real solutions. If you wanted to go ahead and put the imaginary solutions, there they are, but we're not going to use imaginary numbers on this test, so you could pretty much stop right there. All right, last problem about Frankie and Johnny and the Axis Highway once again. This time they're riding towards each other. Maybe they patched up their fight and they want to meet up again. And anyway, we've got the information given here that they are 33 miles apart from each other. And this time Frankie's riding faster. Frankie's rides 20% faster than Johnny. So they begin their ride at the same time and finally meet after 90 minutes. How fast did Johnny ride in miles per hour? So that's our variable there. The question is, how fast did Johnny ride? That's why we want our variable to represent Johnny's speed. In terms of that s, Frankie is 20% faster, which is just 1.2 times s. So there's my expression for Frankie's speed. S is Johnny's speed, 1.2 s is Frankie's speed. My time is 90 minutes, which works out to be 1.5 hours because it does say miles per hour. So I want to convert my time into hours. Keeping in mind my distance equals speed times time basic equation. All right, so everything's kind of based on that. And looking over here at the diagram, Frankie rode this far. Johnny rode this far. The total distance is 33 miles, but we don't know how far each person rode. But if you do work out the speed times time equation for this distance, for Frankie's distance, you get 1.8 s. When you do the same thing over here for Johnny's distance, speed times time, well, that's just 1.5 s. Now, we know that they rode a total of 33 miles. So if you add up each person's distance, it equals 33. So when you add up 1.8 s and 1.5 s, to equal 33, you get 3.3 s. How convenient is that? It equals 33, and so the speed is 10 miles per hour. Hope you enjoyed that. See you soon.